Hello students. Matter around us is present in the form of elements, compounds and mixtures. Elements contain only one type of atoms. At present, 118 elements are known to us. Out of these elements, only 98 are naturally occurring. All these elements have different properties. As different elements were being discovered, scientists gathered more and more information about the properties of these elements. In order to study the properties of these elements in an easy manner, scientists started looking for some pattern in their properties. On the basis of these patterns, they could study such a large number of elements with ease. So, first we can discuss about the early attempts at the classification of elements. In the earliest attempts, the non-elements are classified as metals and non-metals. Later, as our knowledge of elements and their properties increased, further classifications were tried out. So the next topic is Dobereiner's Triads. This classification was introduced by Johann Wolfgang Dobereiner, a German chemist, in 1817. He arranged the elements with similar properties into groups of 3 elements, and he called these groups as triads. And in each triad, the elements were written in the order of increasing atomic masses, and the atomic mass of the middle element was roughly the average of the atomic masses of other 2 elements. For example, this is a Dobereiner's triad. In this triad, the elements lithium, sodium and potassium are arranged in the increasing order of their atomic masses. The atomic mass of lithium is 6.9 and that of sodium is 23 and that of potassium is 39. In this case, the atomic mass of the middle element, that is sodium, is approximately the average of the atomic masses of other 2 elements. Dobereiner could identify only 3 triads from the elements known at that time. These are the 3 triads identified by Dobereiner. Hence, this system of classification into triads was not found to be useful. Next classification was introduced by John Newlands, an English scientist, in 1866. He also arranged the elements in the increasing order of their atomic masses. He started with the element having the lowest atomic mass, that is hydrogen, and ended at thorium, which was the 56th element. He found that when the elements are arranged in the increasing order of their atomic masses, every 8th element had properties similar to that of the first. He compared this to the octaves found in music, that is, in Indian system, sa, re, ga, ma, pa, da, ni, and in Western system, do, re, mi, fa, so, la, ti. Therefore, he called it the law of octaves, and it is known as Newland's law of octaves. And this is the arrangement of elements in Newland's law of octaves. In this arrangement, the properties of lithium and sodium were found to be the same. Sodium is the 8th element after lithium. Similarly, beryllium and magnesium resemble each other. Next, let us check what are the limitations of Newland's law of octaves. And the first limitation is that this law of octaves was applicable only up to calcium. After calcium, every 8th element did not possess properties similar to that of the first element. According to Newlands, only 56 elements existed in nature and no more elements would be discovered in future. But later on, several new elements were discovered whose properties did not fit into the law of octaves. And the third limitation is that Newlands placed elements having different properties in the same slot and elements having same properties in different slot. For example, cobalt and nickel are placed along with the fluorine and chlorine in the same column, but properties of cobalt and nickel are entirely different from that of fluorine and chlorine. Similarly, iron, which resembles cobalt and nickel in properties, has been placed far away from these elements. Thus, Newland's law of octaves worked well with lighter elements only. Next classification was introduced by Dmitry Ivanovich Mendeleev, a Russian chemist. He was the most important contributor to the early development of a periodic table of elements, and he is known as father of periodic table. He started his work with the 63 elements were known. He arranged the elements in the increasing order of their atomic masses. He compared the chemical properties of these elements on the basis of the compounds formed by these elements with oxygen and hydrogen. He found that when the elements are arranged in the increasing order of their atomic masses, their chemical and physical properties repeated after regular intervals. On this basis, he formulated a law, and it is known as Mendeleev's periodic law. It states that the properties of elements are the periodic function of their atomic masses. This is Mendeleev's periodic table. It contains vertical columns called groups and horizontal rows called periods. The structures of oxides and hydrides formed by each element is represented at the top of each column, that is, at the top of each group. For example, elements in the first group will form oxides having general formula R2O and hydrides having general formula RH. Mendeleev left some gaps in his periodic table, and he predicted the existence of some elements that had not been discovered at that time. Next, let us discuss what are the achievements of Mendeleev's periodic table. Mendeleev named them by prefixing a Sanskrit numeral, that is ega, which means 1, to the name of preceding element in the same group. For example, the elements such as scandium, gallium and germanium were not discovered at that time, but they have properties similar to ega boron, ega aluminium and ega silicon respectively. Mendeleev predicted the properties of ega aluminium, and later when gallium was discovered, these properties are proved to be correct in the case of gallium, and it replaced the ega aluminium in Mendeleev's periodic table. Second merit is that when noble gases were discovered, they could be placed in a new group without disturbing the existing order. Noble gases were discovered very late because they are very inert and present in extremely low concentrations in our atmosphere. Inert means less reactive. Examples for noble gases are helium, neon, argon, etc. Next, let us discuss the limitations of Mendeleev's periodic table. Mendeleev could not place hydrogen in a correct position as it resembles both alkali metals and halogens. Examples for alkali metals are lithium, sodium, potassium, etc. Electronic configuration of hydrogen is similar to that of alkali metals, and like alkali metals, hydrogen combines with halogens, oxygen and sulfur to form compounds having similar formulae. Like halogens, hydrogen exists as diatomic molecules, and it combines with metals and nonmetals to form covalent compounds. Second limitation is that Mendeleev could not give a correct position for the isotopes of elements. Isotopes are atoms of same elements having same atomic number but different mass number. For example, chlorine has two isotopes Cl35 and Cl37, but Mendeleev didn't place them in separate slots. Third limitation is that the atomic masses do not increase in a regular manner in going from one element to the next, and these two isotopes have different masses. For example, cobalt having atomic mass 58.9 appeared before nickel having atomic mass 58.7. These are the important limitations of Mendeleev's periodic table. I hope you understood the topic. Okay, thank you.